In this video, I will be going over a test that I gave on length, area, and volume. So, I will be showing you how to find the area and the perimeter and the volume just of a variety of different kinds of shapes. Well, so of course the perimeter is just the sum of all the sides. So I think I'll label all the sides. So let's say that this is side number 1, and this is side 2, and 3, and 4. So let's just find all these lengths. So length 1, I can just count these squares. I see 4 on the right, 5 on the left, so that's 9. Length 2 is vertical, so I can count. That is 6. Length 3 is horizontal. That is 5. Length 4 is the only one that takes a little bit of effort. Because it's slanted, we need to do the Pythagorean Theorem to find it. So that might look something like this. If I make a right triangle so that the line I want the length of is the hypotenuse, and then if I count the horizontal, which is 4, and the vertical, which is 6, then I can do the Pythagorean Theorem to find this. So this length is going to be the square root of 4 squared plus 6 squared. And I'll use my calculator to help me out. So 4 squared plus 6 squared is 52. So this is the square root of 52. So if I add all of these up, that's the perimeter. So I will just have 9 plus 6 plus 5 plus the radical 52. So that is 27.21. To find the area of a polygon, I'm going to split this up into areas that I can easily calculate. So if I just draw a vertical line right here, that's the simplest thing to do. And then I will have area 1 and I will have area 2, a triangle and a rectangle. So I will find both of those areas and add them up. So area 1 is a triangle. So the area of a triangle is 1/2 base times height. The base is 4, and the height is 6. So half of 4 is 2. 2 times 6 is 12. So area 1 is 12. Okay, now let's talk about area 2. Area 2 is a rectangle, so that's just going to be base times height. So that is going to be 5 for the base. And the height again is 6. So that's going to be 30. So if I add these up, that's going to be 42. For number 3, let's see, we're given the radius, and we're told that the shaded sector has an area of 57 square centimeters. What is the measure of the central angle? So as soon as they mention sector area, I'm going to write down the sector area formula, which is this. The area of a sector is always going to be some fraction of the whole area of a circle. And the whole area of a circle is pi r squared. So this is the formula for the area of a sector. Now, the thing that we're looking for is the measure of the central angle. The central angle is this right here, and we call it theta. So that's what we are looking for. So we're looking for theta. That means we must be given A and R, you know, the sector area and the radius. So let's fill in those two values. So the area is 57 square centimeters, so I'm going to put 57 right here is equal to theta over 360, and then pi, the radius is 9, so pi 9 squared. So we're looking for theta, so we just need to get theta by itself. So the easiest thing to do is to multiply both sides by 360. That way the 360s cancel each other out. Okay, 20,520. Is equal to theta. 9 squared is 81. So I started to write pi 9 squared, but I think I'll go ahead and write 81 pi, because that's the same thing. All right, this right here is 81 pi. So now to get theta by itself, I'm going to want to divide both sides by 81 pi. All right, because that will cancel out the 81 pi, leaving theta by itself, which is what I wanted the whole time. Okay, so 20,520 divided by 81 pi. Okay, so that's going to give me 80.64. Got to round up. Okay, one more little thing before I move on. Just then, notice how I set this up as a fraction with a numerator and a denominator. A common mistake that I see is students will do 20,520 divided by 81 pi. And they think they're going to get the same answer that I did, but this is a completely different answer. If you're going to type it in your calculator this way, the 81 pi needs to be in parentheses. So you would need to write 20,520 divided by, and then put the 81 pi in parentheses. And then you get the same answer. So watch out for that mistake. The bold arc has a measure of 146 degrees. All right, so I'm actually going to put the 146 at the central angle because that's the same thing. All right, bottom line is that's theta. Right there. Okay, and a length of 50 feet. So fine, the arc length is 50 feet. What is the circle's radius? So as soon as I see that we're talking about the arc length, I'm going to start by writing the arc length formula. Well, whoops, I don't mean to write A. I usually write L for arc length. Okay, the length of an arc is some fraction of the entire circumference of the circle. And the formula for the circumference of a circle is 2 pi r. So it's some fraction of 2 pi r. Okay, in this particular problem, we're being asked to find the radius. So this is our target. That means that we must be given L and theta. And that's here and here. So 50 is the arc length. So that goes right here. Theta is 146 for 360. Okay, times 2 pi r. I like to reduce these fractions when they occur. So 146 over 360. Okay, that didn't reduce very much. 73 over 180, but I'll still take it. So this gives me 50 is equal to 73 over 180. And then I've still got times 2 pi r. So next I would multiply both sides by 180 in order to get rid of this denominator. So multiply by 180 on both sides. All right, so the 180s will cancel each other out. $9,000. So I now have 9,000 is equal to 73 times. Well, you know what? Let me go ahead and just write what this is. So the 180s are gone, so that leaves me with 73 times 2 pi r. So I can definitely do 73 times 2 to simplify this a bit. So 146. So what I really have is 146 pi r. So my goal is to find r. So it's time to divide both sides by 146 pi. All right, so these will cancel each other out, and this should give me the answer. Divided by 146 pi. So that's 19.62. All right, 19.62 feet. Okay, so now we're being asked to find the perimeter of this strange shape. So perimeter is still just the sum of all the sides. So look at the lengths that we have. I'm going to think of this as length number 1, and this is like length number 2, and this is number 3, and this would be length number 4. Okay, just so I can you can follow what I'm doing. So the perimeter is the sum of all 4 of these lengths. Notice I'm not adding this line on the inside. That would be silliness. So I'm going to just record that length 1 is 20. All right, that's just given. Length 2 is 52, also given. Length 3 is 48, also given. So the only one that takes any effort is the length 4. Okay, because length 4 is this arc, which is a quarter of a circle. It's a quarter of a circle. All right, so the circumference of a circle is 2 pi r. Okay, 2 pi r. That's the circumference. That would be a whole circle. Now r, I bet we know what that is. And sure, look at this. Okay, if this was a whole circle, then this would be the radius of that circle. So the radius is 20. Okay, so that's going to make this, instead of 2 pi r, I'm going to have 2 pi 20. Okay, now this is the circumference of a whole circle. But what we have is only a portion of the circumference. It is 1/4 of the circumference. So I'm going to go ahead and do 1/4 right here. All right, if you're trying to use some kind of a formula or something where they have like theta over 360 or something like that, well, theta is 90 degrees right here. So if you just blindly use the formula and you do 90 over 360, guess what? That's 1/4. All right, but common sense, you can just tell this is a quarter of a circle, so 1/4. of the circumference will be needed. Okay, let's go ahead and put this in the calculator and see if we can clean this up a little bit. If I do 1/4 of 2 pi 20, let's see what happens. 10 pi. Very nice. Okay, so that's all 4 lengths. So for the perimeter, I will just add them up. So I will have 20 plus 52 plus 48 plus 10 pi. 151.42. Got to round up. 151.42. Okay, this is the first one that they're making us write the units ourselves. If you leave off the units, you're losing half of a point. The lengths were all given in yards, and the perimeter is still a length, so I'm just going to put yards again. For number 6, we're supposed to find the area of this combination shape. And when you find the area of a combination shape, just split it up into 2 or more areas that you can easily find. So I will think of this as area number 1, and I will think of this as area number 2. So let's start with area number 1. This is a triangle, so the area is going to be 1/2 base times height. So that's 1/2. The base here is 48. All right, the height takes like 1 second of extra thought because there's no number here where the height is, so I have to realize, wait a minute, right here is, they have 20. Now that's the radius of this circle. Okay, so it's going to be 20 here, but guess what? It's also going to be 20 here. All right, so the height is 20 because radius of a circle is always the same. Okay, half of 20 is 10. 10 times 48 is 480. Okay, so that's area number 1. Now, let's talk about area number 2. Area number 2 is a quarter of a circle. Let's talk about the area of a whole circle. Well, that's pi r squared is the formula for the area of a whole circle. So, first of all, I know what the radius is. Okay, the radius is 20. So that makes this pi 20 squared. All right. However, that would be the area of an entire circle. This is only a quarter of a circle, so I'm going to put 1/4 of this. So let's see if that comes out to be a nice even number. Okay, 1/4 pi 20 squared. 100 pi. So if I add these up, that should be the area of the whole shape. So I've already got 100 pi in there, so I'm just going to put plus 480. 794.16. Got to round up. 794.16. Okay, and the units. The lengths were given in yards, but this is an area, so we're going to write yards squared, square yards. Okay, this shape is a prism, And I know this because a prism has a congruent shape on both ends. And whatever that congruent shape is, that's the base. So when I look at this, uh-oh, that's white. Okay, I see a triangle on this end. Okay, and then I see another triangle on the other end. All right, here's another triangle. Okay, so because I have two congruent shapes across from each other, I know this is a prism. Another thing I should point out right now, later we'll be talking about the height of this prism. Okay, a really common mistake that I see. Some students will think that the height of the prism is 12 because they're used to thinking of the height as being up and down. But that's not the way it works for a prism. The height is the distance between the two bases. So this 9 over here is actually the height. Okay, so keep that in mind. This 12 is the height of the triangle, but 9 is the height of the prism. Okay, so that's good enough. I think I'm going to erase these lines. So, how do I find the volume of a prism? Let's start by writing the formula for the volume of a prism. Okay, the volume of a prism is the area of the base times the height. Okay, and just remember, this is the area of the base. Okay, that's what this B is. So I just told you that the two triangles are the bases. So when they say area of the base, they're talking about the area of this triangle. So we need to find that before we do anything else. So the area of the base, well, the area of a triangle is 1/2 base times height. The base of the triangle is 25, and the height of the triangle is 12. Okay, pretty much messed that up. 1/2 25 times 12. Why do I keep writing 11? That's 150. Okay, so that goes right here, all right? That's the area of the base. So now I have the volume is equal to 150, okay, times the height of the prism, which is 9, as I said before. So 150 times 9 is 1,350. Okay, we have to include our own units. The lengths were given in feet. So volume will be feet cubed, or cubic feet. Let's see. This shape is a pyramid. You can tell this because there's only one base, which is right here. Okay, and all the edges lead to an apex, so that makes this a pyramid. Now, this shape has a volume of 1,152. Find the height. Well, they're giving me the volume of a pyramid, so I need to go ahead and write down the formula for the volume of a pyramid. So the volume of a pyramid is 1/3 the area of the base times the height. So let's start by finding out what the area of the base is. All right, the base is this rectangle. So the area of the base is just base times height, you know, like basically length times width. So that's going to be 18 times 12. So area of the base is, so 18 times 12, 216. Okay, so that's going to go right here. Also, we know the volume, so I can substitute that in. So I have 1,152 is equal to 1/3. Okay, and then the area of the base is 216 times the height. So what I usually do is to multiply both sides by 3. Now I could multiply 1/3 and 216, but I'm going to just keep doing what sort of always works. So if I multiply by 3, these will cancel each other out. All right, and I'll have 1,152 times 3. So that's 3,456. Is equal to 216 h, the height. And then to get the height by itself, all I need to do is divide both sides by 216. All right, because these will cancel out and leave h by itself. So I already have that number, so I can just go divided by 216. So that's going to be 16. Okay, the units of length are centimeters, and height is a length, so I'm just going to write 16 centimeters. Problem number 9. Which shape has the largest volume? Choose one, only one. I don't have to calculate the volume of each of these shapes. Clearly, option B is half of option A, so I can forget about option B. That's not going to be the largest. Option C, this pyramid, notice it has the same height. It has the same height as this cylinder. So this, did I say pyramid? This cone would fit inside of the cylinder like this, and there'd be like all this space left over. So clearly the cylinder is bigger than the cone. So it really just comes down to these two. So I'll just calculate the volume of each of these and see which one is bigger. So for a sphere, the volume is 4/3 pi times the radius cubed. 4/3 pi r cubed. And for a cylinder, the volume is the area of the base times the height. So look off to the side real quick. The area of the base is a circle. That's pi r squared. All right, this is the base. So pi r squared, that's pi 4 squared. So the area of the base is 16 pi, and that's got to go right there. So that means this volume is going to be 16 pi times the height, which is 4. Okay, so getting back to the volume of the sphere, that is 4/3 pi 4 cubed. Okay, I'm getting this, but I'm just going to use a decimal for easy comparison. So 268.08. All right, cubic centimeters. And now how about this? Okay, 16 pi times 4. That's 201.06. Okay, so clearly the sphere has the larger volume. So the answer is A. This pencil is made of a cylinder and a cone. The pencil's diameter is 6 millimeters. All right, that's marked down here. Find the pencil's volume. Okay, so I am going to think of the cone as volume 1, and I will think of the cylinder as volume 2. So volume 1. The volume of a cone is 1/3 area of the base times the height. So the area of the base is a circle. Okay, I need to know the radius of the circle because the area of a base is pi r squared. Okay, so I need to know what the radius is. Well, the diameter is 6 millimeters, so the radius is 3. So that's going to be pi 3 squared, which is 9 pi. So that's going to go in right here. So that means that volume 1 is 1/3 9 pi times the height. The height of the cone is 33 millimeters. Okay, let's see what that gives you. So 1/3 9 pi times 33. That's 99 pi. So volume 1 is 99 pi cubic millimeters. So now let's find volume 2. Volume 2, the volume of a cylinder is simply the area of the base times the height. Well, the base of the cylinder is the same as the base of the cone. So we can use that same 9 pi for this b value as well. So this is just going to be 9 pi times the height of the cylinder, which is 160. All right, so let's see what that is. (1,440 pi). Okay, for the total volume, I need to add these up. So I already have this typed in, so I'm just going to do plus 99 pi. So I get this. Did they ask me for the exact? I'll write both answers down. Somebody's going to give me this. 1,539 pi. Okay, cubic millimeters, or in decimal form, that's 4,834.91. Check it out. Here's a bonus question. It's very, very interesting. Multi-layered, if you will. We need to find the volume of this shape. All right, it's a Rolo candy. But the volume of this shape could be thought of as a cone with a smaller cone subtracted from it. So it's basically a full cone where the top part of the cone has been chopped off and taken away. So it's a cone minus, it's a large cone minus a smaller cone. So how am I going to write this down? Okay, so I'm going to write big cone minus small cone. that will give us the volume. If I take this large cone and I subtract this small cone that's missing, then that will leave the shape that we have. So all I need to do is find these two volumes. Now, the volume of the big cone will be easy to find because I have the diameter, which will give me the radius, so I can. That's not going to be a problem. The tricky thing is I don't have the diameter of the smaller cone right now, so I need to do some kind of a trick to figure out what this length is right here. All right, I need to know what the diameter of the small cone is. And to do that, I'm going to need some similar triangles. All right, they kind of gave me that hint right here. So thinking back to what we knew a long time ago, I've got this, I could look at the side of this large cone. If I look at it sideways, it's a large triangle. Okay, just forget that it's 3D for a minute. All right, so I've got this large cone. And the bottom of this triangle is 28. Okay, and the height of this triangle is 56. Okay, I'll just put a little height here, and that's 56. So then we have a smaller triangle. Okay, now this is the smaller triangle that's missing. I want to find out what the bottom of the small triangle is, but what I do know is I do know the height of the small triangle, and that's 40. Okay, so the essence of what we know about similar triangles is their corresponding lengths are proportional. What that means is if I make a fraction using the large triangle, it should equal the same fraction for the smaller triangle. So in other words, say if I made a fraction that went, I'm going to do the base over the height. Okay? So what I'm saying is base over height for the big triangle should equal base over height for the small triangle. All right? Corresponding ratios are proportional. So that's going to give me, all right, so I did base over height. I'm going to do base over height again. So that would be x over 40. So because these triangles are similar, then these ratios should be equal. Now, I always like to reduce my fractions when I can. You don't have to, but I like to. So I'm going to go 28 over 56. Okay, that's 1/2. So I have 1/2 is equal to x over 40. And now I'm going to multiply by 40 on both sides. Okay, because that will get x by itself. But now basically I have x, 40 is 40 times a half. Half of 40, if you will, is 20. So x is 20. So what I just found was the diameter of the base turns out to be 20 millimeters. All right, that's what I needed to be able to go back and solve the rest of this problem. So now let's go back and solve the rest of this problem. So the volume of the big cone. The volume of a cone is 1/3 area of the base, okay, times the height. Maybe I'll just write it down. So 1/3 area of the base times the height. And I'll do the same thing for the small cone. 1/3 area of the base times the height. So I'm going to have 1/3 Now the area of the base, for the large cone, we're talking pi r squared. So the radius for the large cone is half of 28. So that's 14. So that's going to be pi 14 squared. Okay? So that's the radius, that's the area of the base of the large cone. Now, the height of the large cone is 56. So this will be times 56. Not equals minus. So here comes the small cone. 1/3 area of the base times the height. So the area of the base for the small cone, again I'm going to do pi r squared, but the radius is 10, right? Because the diameter was 20, so the radius is 10. So this is going to be pi r squared will become pi 10 squared times height. Now the height of the small cone is right here. It's 40. Okay? Now really, I could type this entire thing in my calculator all at once, and then that should be the answer to the question. Okay? Maybe I'll show it both ways. Okay? So let's see what we would get if we did it separately. So let's see if I did 1/3 times pi r squared, so pi 14 squared times 56. Okay, so that's 11,494. .04. Okay, and now on the other side, I've got 1/3 pi 10 squared times 40. So that's 41,088. No, 4,188. Was that 0.79? Is that what I saw? Yes. Okay, so if I subtract these two, that should be the volume of the leftover shape. I'm taking the large cone and I'm subtracting away the smaller cone off the top. So that's what I'm going to do. $11,494.04 minus 41,000. Why do I keep doing that? 4,188.79. So that is 7,305. Is there a spot for this? 7,305.25. The units, this is volume, so since the lengths are millimeters, volume will be cubic millimeters. Okay, so that was a very interesting problem. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.